Lesson 10, the effect of extremes. So what we did for this lesson is we went on to this link here, and we played with this, it's called an applet, a little interactive digital dot plot. So it's not interactive here on the Google Doc. So I'm going to have to click on this link. So you will click on this link if you're doing this from home. And it will bring you to this website. And you will scroll down to this one, separated by skew. And it may take a moment for the actual little thing to open. So what you're going to do when it opens is you're going to click all of these things, which will show the dot plot, will show the plot mean, median, and the statistics. And I can't with my Apple Pen draw on this website, so I'm just going to have to explain it. Where it says data up at the top and it has the numbers 6, 7, 8. Oh no, maybe I can. Is it going to let me do that? Then that is where, that's the data, and then it's a graph down here as a dot plot. So let's go back to our notes and see what we're supposed to do. So we start with this data set that it gives us, and then we do these things where we have to follow some instructions. So first we add two values to the original data set that are greater than 14. So let's do that. We'll go back to the video here, and I'm going to add in greater than 14. How about 16 and 17? So I'm going to put commas in between, and then I have to replace that little bracket thingy, which is that, and then press return, and I will get, go away keyboard, I will get a slightly different situation going on. Notice I have my new plots here. I have 16 and I have 17 are added here to the right. And look at my new mean. My new mean is different, 10.65, but my median is still 10. So 10 is still the middle number here in our dot plot. It's still the middle value because there's a number of different 10s up here. So let's record that information. Mean, of course, is the average. It's what you get by adding all the numbers together and dividing by the number of turns. But the median was still 10 like it was up here. Mean got bigger, median still 10. Now we're going to add two values that are less than 6. And we got to go back to the original data set, and we're going to see what happens to the mean and the median. Okay, so I'm going to press this little arrow button up top. It will reset it back to the original data set. I'm going to have it show the, what is it showing that? The dot plot. Clicking. Okay, I'm going to try to enter the values first. So I'm entering values that are, it's not responding. What is going on? I'm going to refresh. Okay. All right. So now I'm going to try to go back in. Okay, I'm entering values, but is not responding to my iPad. Okay, I'm going to enter a couple values that are less than 6. So I don't have to enter them in order. I can put them up here. So I'm going to try maybe 2 and 4. You can choose whichever ones you want, and then I got to put my little brackety thingy back on. Press return. Now I'm going to have it show all of my things here. Okay, so the median is still 10, but with these two smaller values, the mean, the average, has shifted down to 9.3. So median is 10, mean is 9.3. So we're going to go record that. Oops. Median is 10, but the mean is 9.3. Now you on your own will follow these instructions, and you'll record your own mean and median with the instructions. You have to reset it back to the original data set. Reset back to the original, and you'll find the mean and medians. And then you're going to answer this question. Do extreme values, which we have another word for, which is outliers, have more effect on the mean or the median? And as we found in class, and as we can see here with these first two that we did together, the median actually stayed the same when I added those extreme values at the high end and the low end. And so we determined that extreme values have more effect on the mean, the average, than the median. And you can answer this question why. So I'm going to have you think about that. Why is that? Now you're going to go back to that applet, and you're going to create a couple of different distributions, and you can look on your lesson 4 notes to remember what these are: uniform, skewed right, skewed left, symmetric. You're going to have to go back and change the numbers in the data set so that you get, in this case, a uniform distribution with data between 4 and 12, or a skewed right with most of the values at 10. So you'll go into that applet, change the numbers in the data set to meet these qualifications, and then you'll write down your mean and median. Okay, then we made some general statements, some conclusions from this experimentation. So which one, the mean or the median, gives equal importance to each value when finding the center? And which one tells you the middle value, so that changes to a single value do not affect it much? So I want you to pause, think about it. All right, back from the pause, let's see if you got it right. The mean is the one that gives equal importance, and the median tells you the middle value, so changes to a single value don't really affect it that much. Okay, so let's look at one more situation here. We have the time it takes to hit a dartboard in seconds. So you're throwing a dart, and how many seconds it takes for it to hit the dartboard. And so we have decimal numbers here, 1.4, 1.5. So in this, so you can pause a moment and see if you can calculate the median and the mean. So the median is 1.4, right? This is a symmetric distribution, so the median is easy to see. It's right in the middle. And in symmetric distributions, the median and the mean are actually the same. So the mean would also be 1.4, and you can prove that to yourself by adding up all these values and dividing by that. So when a distribution is, in this case it's symmetric, the median and the mean are both found in the middle. Now let's take this same distribution. Notice we have these, all the same distribution here as we do up here, but instead of having these two down here, they are way down here as outliers. So much faster. Somebody threw a dart much faster a couple of times to hit the dartboard. So we have a different looking distribution. We now call this non-symmetric, right? And you're going, I gave you the mean, you figure out the median, and you can write it in there. So pause and figure out the median. If you said 1.4, you are right. Notice that the median actually didn't change when we added in these extreme values. Similarly to what happened here when we added in higher values or lower values, the median stayed the same. So which of these, the mean or the median, is more resistant to extreme values than the other? So pause a moment. This is my little pause button icon. Pause and think about that. So if you said the median is more resistant to extreme values than the mean, you are correct. Okay, last one. Which one is the preferred measure of center when a distribution is skewed or there are extreme values, outliers? Pause and think about this. If you said that the median is the preferred value, you're correct. But if we have a symmetric distribution like we do up here, the mean is the preferred measure of center. Okay, those are the notes for lesson 10.